Hi students, today we are learning the topic is properties of eigenvalues. In the previous lecture, we discussed the definition of eigenvalues and eigenvectors and some problems also we discussed. So next one is properties of eigenvalues. Okay, see that first one. If lambda is eigenvalue of the matrix A, then lambda is also eigenvalue of A transpose. And A is a given matrix A and its transpose of the matrix A transpose having the same eigenvalues, no change. And okay, now this first one. Okay, second one, if lambda is not equal to 0 is eigenvalue of the non-singular matrix A, then 1 by lambda is an eigenvalue of A inverse. So A is any matrix, lambda is the eigenvalue of A, then inverse matrix eigenvalue is 1 by lambda, that is reciprocal of lambda, that is 1 by lambda is eigenvalue of A inverse. So third one, if lambda is an eigenvalue of the matrix A, then lambda power n is eigenvalue of A power n, where n belongs to capital N. And lambda is eigenvalue of A, then lambda square is eigenvalue of A square, lambda cube is eigenvalue of A cube, up to so on. That is the eigenvalues. So fourth one, if lambda is eigenvalue of the matrix A, then lambda plus or minus k is eigenvalue of A plus or minus ki. So A plus or minus k is the polynomial of first degree, and A is lambda is eigenvalue of A, then automatically lambda plus k is eigenvalue of A plus ki, and also lambda minus k is eigenvalue of A minus ki. So this is the eigenvalue of A polynomial. Okay, next one, if lambda is eigenvalue of the matrix A, then k lambda is also eigenvalue of k A, and any scalar is multiplied with matrix A, then the same scalar is multiplied the eigenvalue. Okay, now this is another one. Next one, the eigenvalues of a triangular matrix and diagonal matrix or the diagonal elements of the matrix. Okay, directly eigenvalues of the triangular matrix and diagonal matrix, only diagonal elements are automatically eigenvalues of that matrix. Okay, so next one, the eigenvalues of a real symmetric matrix is always real. Any real symmetric matrix, the eigenvalue is always real. And so this is one of the properties of eigenvalues. Next, continuation. So next one, the sum of the eigenvalues of a matrix is the sum of its principal diagonal elements. And without finding the sum of the eigenvalues, directly trace of the matrix, and that is the sum of the diagonal elements. Okay, this is one of the property. Next one, the product of the eigenvalues of a matrix is the determinant of the matrix, and the product of the eigenvalues is equal to the det of the given matrix. So next, if lambda is not equal to 0 is eigenvalue of the matrix A, then det A by lambda is eigenvalue of adjoint of A. The lambda is eigenvalue of A and A, then adjoint of A is eigenvalue is det A by lambda. So next one, if A and P are two square matrices of same order and P is non-singular, then A and P inverse AP have same eigenvalues. So here P inverse AP and A both are similar matrices. And so similar matrices means having the same eigenvalues. P is any non-singular matrix. Okay. Next, if lambda is eigenvalue is an orthogonal matrix, then 1 by lambda is also its eigenvalue. So A is any orthogonal matrix. Orthogonal matrix means A inverse is equal to A transpose. And A transpose means same eigenvalue. A inverse eigenvalue 1 by lambda. So that 1 by lambda is also automatically eigenvalue of the given matrix. So next one, if lambda is eigenvalue of the matrix A, then A naught plus A1 lambda plus A2 lambda square plus up to so on n lambda power n is equal to f of lambda. That is a polynomial of the eigenvalue. Is eigenvalue of polynomial matrix f of A. That is any nth degree polynomial in matrix A. Then its eigenvalue is automatically substituting A place lo lambda replacing and so that is called, that is f of lambda is the eigenvalue of polynomial matrix f of A. Directly A place lo lambda replace cheyalandi. So this is the properties of eigenvalues. So next one, properties of eigenvectors. If x is an eigenvector of matrix A corresponding to the eigenvalue lambda, then kx is also eigenvector of A corresponding to same eigenvalue. So if x is eigenvector ayind then any multiplying with the constant to the eigenvector, that is kx is also eigenvector to the same eigenvalue. Same, and x kx is also eigenvector corresponding to same eigenvalues where k is any non-zero. Second one, if x is eigenvector of matrix A, then x cannot correspond to more than one eigenvalue of A, and every eigenvector is corresponding to only single eigenvalue, cannot more than eigenvalues. Next, third one, the eigenvectors corresponding to distinct eigenvalues of a matrix are linearly independent, and if the eigenvalues are distinct, then automatically eigenvectors of that eigenvalue is always linearly independent. Next, fourth one, the eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix are orthogonal. The distinct eigenvectors is always mutually orthogonal. So this is the properties of eigenvectors. Okay. So next, orthogonal vectors. The definition is orthogonal vectors. Okay, orthogonal vectors. The vectors x1 and x2 are orthogonal if x1 transpose x2 or x2 transpose x1 is equal to 0, and x1 transpose into second vector x2, we getting the 0 vector, that is 0 value, or x2 transpose into x1, that is equal to 0, then both vectors x1 and x2 are orthogonal vectors. Okay, these are definitions. So next, see that example, see that. Okay, na example on eigenvalues, properties of eigenvalues and eigenvectors. Okay, na. Okay, first example, if A is equal to the matrix given, find the eigenvalues of the following matrices. So matrix A transpose, matrix A inverse, matrix A square, matrix 4A, matrix A square minus 2A plus I, next to matrix adjoint of A. So using the properties of eigenvalues. Okay, na. First of all, finding the eigenvalues of the given matrix. So given matrix A, so the characteristic equation data of A minus lambda I is equal to 0 or using that formula. So already we discussing the previous lecture. So using this formula we have to finding the first of all characteristic equation and next finding eigenvalues. So next S1, S2, S3 find out. So S1 is equal to trace of A gada 3 plus 5 plus 3 gada 11. Next S2 is the sum of minus of principal diagonal elements of A, that is equal to first 3 element with minor plus 5 elements minor, next to plus minor of 3. So that is equal data of plus data of that is equal 15 minus 1, 9 plus 9 minus 1, 15 minus 1, that is equal 36. S3 is equal to det of A. So det value finding 3 into 15 minus 1 plus 1 into minus 3 plus 1 plus 1 into 1 minus 5 is equal to 36. So that is equal to, from equation 1, substituting here S1, S2, S3, substituting the values, that is equal to lambda cube minus 11 lambda square plus 36 lambda minus 36 is equal to 0. So by inspection method, first of all, lambda is equal to substituting. Which one is? So clearly lambda is equal to is one of the root. Remaining dividing by 2, getting this quadratic equation. Lambda square minus 9 lambda plus 18 is equal to 0. That is equal to factorization. Lambda minus 2 into lambda minus 3 into lambda minus 6 is equal to 0. So therefore lambda is equal to 2 comma 3 comma 6. This is the eigenvalues of the given matrix A. Okay. So using this eigenvalues by also using properties of eigenvalues, finding the all matrices. Okay. So this is the eigenvalues of A, 2, 3, 6. Yeah, first one, the eigenvalues of A, the matrix A, given matrix, lambda is equal to 2 comma 3 comma 6. Okay, na? Next one, the eigenvalues of A transpose. A transpose is equal to both A and A transpose have the same eigenvalues here. So transpose of the A eigenvalues are same. That is lambda is equal to 2 comma 3 comma 6. Next, the eigenvalues of A inverse, that is equal to A inverse eigenvalues means 1 by lambda, that is equal to 1 by 2 comma 1 by 3 comma 1 by 6. Next, the eigenvalues of A square. So power of A square is that. So eigenvalue is also power 2. Lambda square means 2 square comma 3 square comma 6 square, that is equal to 4 comma 9 comma 36. Next, the eigenvalues of 4A, the 4 into A, then 4 is also multiplication with the eigenvalue 4 lambda, the 4 into 2 comma 4 into 3 comma 4 into 6, that is equal to 8 comma 12 comma 24. Next, the eigenvalues of, this is a polynomial matrix here, A square minus 2A plus I, and A place lo lambda replace chal, unit matrix place lo constant 1, that is equal to eigenvalue of this polynomial is lambda square minus 2 lambda plus 1. So first 2 lambdas substitute. 2 square minus 2 into 2 plus 1, comma next third eigenvalue. 3 square minus 2 into 3 plus 1, next to lambda is equal to 6. 6 square minus 2 into 6 plus 1, that is equal to simplification 1 comma 4 comma 25. This is eigenvalues of the given polynomial matrix. So next one, the eigenvalues of adjoint of A. So adjoint of eigenvalue is det A by lambda kada. Det find out already det find out chesam 36 వచ్చింది. Next lambda for each eigenvalue. So that is 36 by 2 comma 36 by 3 comma 36 by 6, that is equal to 18 12 6. So this is the eigenvalues of the given matrix by using properties of eigenvalues. Okay. So next one. So find the sum and the product of the eigenvalues of the matrix. And they are directly finding sum and the product of the eigenvalues, and without finding the eigenvalues using the properties of eigenvalues. So sum of the eigenvalues is trace of the matrix. Product of the eigenvalues is determinant of the matrix. Using that properties. So given matrix A. So sum of the eigenvalues A is equal to trace of A, that is equal to 4 plus 3 minus 3, that is equal to 4. Next, product of the eigenvalues of A, that is equal to det A, that is equal to det means 4 into minus 3 plus 8 minus 6 into minus 3 plus 2 plus 6 into minus 4 plus 3, that is equal to 4 minus 4. This is the product of the eigenvalues. Okay, na? So next third example, from the matrix whose eigenvalues are alpha minus 5 comma beta minus 5 comma gamma minus 5, where alpha comma beta comma gamma are the eigenvalues of A. So you are finding the matrix అండి. Which matrix? That matrix having the eigenvalues are alpha minus 5 comma beta minus 5 comma lambda delta minus 5. So alpha beta gamma are eigenvalues of A కదా. So using that one of the properties of eigenvalues, that is lambda minus k కదా. Lambda minus k is the eigenvalue of a minus ki కదా అవునా. ఇక్కడ లాంబ్డా ఈజ్ ఈక్వల్ ఎంత, ఆల్ఫా అజంప్షన్, k వాల్యూ 5 అండి. సో దట్ ఈజ్ ఈక్వల్ యూజింగ్ దట్ ప్రాపర్టీ. సో గివెన్ మ్యాట్రిక్స్ A, so we know that lambda 1, lambda 2 and lambda 3 are eigenvalues of the matrix A. Then lambda minus 1 minus k, lambda 2 minus k and lambda 3 minus k are the eigenvalues of A minus ki. This is a property. Already మనం discussing the properties లో, there is a polynomial. So where k is equal to మనకు value 5 కదా, that is equal to required matrix is A minus 5i, that is A minus ki కదా. K is equal to 5 here given. This is alpha beta gamma ఏమో lambda 1 lambda 2 lambda 3 అండి. So that is equal to A minus 5 into I. So the simplification is minus 6 minus 2 minus 3 4 0 minus 6 7 minus 8 4. This is the required matrix. Okay, so see the next question. So find the eigenvalues of the matrix A and also find the eigenvalues of A inverse adjacent of A, 2A square minus 1 by 2A plus 3i. Okay na. First of all, finding the eigenvalues of A. This is the given matrix, is upper triangular matrix and we know that one of the property of eigenvalues, the eigenvalues of a triangular matrix are diagonal elements. So your diagonal elements 6 3 3 kada. So this is the eigenvalues of the matrix A. Since the eigenvalues of the upper triangular matrix are its principal diagonal elements, therefore eigenvalues of A, that is equal lambda is equal to 6 comma 3 comma 3. Next finding, first one, the eigenvalues of A inverse. A inverse is equal to eigenvalue 1 by lambda, that is 1 by 6 1 by 3 1 by 3. So next one, adjacent of A. The eigenvalues of adjacent A is equal to det A by lambda kada. Det A is equal finding just in product of the eigenvalues say det 54. So 54 by 6 comma 54 by 3 comma 54 by 3, that is equal to 9 18 18. Next, the eigenvalues of the polynomial 2a square minus 1 by 2a in plus 3i. So that is equal to polynomial matrix ki eigenvalue is f of lambda, అంటే a place లో lambda replace, that is equal to 2 lambda square minus 1 by 2 lambda plus 3. So lambda place లో eigenvalue substitute చేయండి. First eigenvalue 2 into 6 square minus 1 by 2 into 6 plus 3. Second eigenvalue 2 into 3 square minus 1 by 2 into 3 plus 3. Next eigenvalue is 2 into 3 square minus 1 by 2 into 3 plus 3, that is equal to 72 comma 39 by 2 comma 39 by 2. So this is the eigenvalues of the given matrix. Okay, see the next question. Find the eigenvalues and orthogonal eigenvectors for the given matrix. And first of all, finding the eigenvalues and next for each eigenvalues we have to finding the eigenvectors. Next one, that eigenvectors are orthogonal or not. If orthogonal, that is directly orthogonal vectors. If not orthogonal, then finding the required orthogonal vectors. Okay na. So these are very very important in long question. Okay, same. First finding characteristic equation. Okay na, using this formula. Next finding S1 S2 S3. S1 is equal to trace of the matrix 1 plus 4 plus 9 is equal to 14. So S2, sum of minus of principal diagonal elements of A, that is equal to det of 4 6 6 9 plus data of 1339 plus 122. So that is equal to 36 minus 36 minus 9 plus 4 minus 4, that is equal to 0. S3 data of A, date value is getting the 0 only. Substituting S1, S2, S3 in equation 1. From equation 1, lambda cube minus 14 lambda square plus 0 minus 0 is equal to 0. So lambda square into lambda minus 14 is equal to 0. Therefore lambda is equal to 0, 0, 14. This is the eigenvalues of the given matrix. Okay, now for each eigenvalue you have to finding the eigenvectors. Same procedure in the previous lecture we discussing. Yes. So let x be the eigenvector corresponding to eigenvalue lambda of A. Then the matrix equation is A minus lambda I into x. First case, if lambda is equal to 14 only. So lambda place lo 14 replace change, that is A minus 14i into x is equal to 0. So A minus 14i means in the given matrix lo only diagonal elements lo minus 14 cheyali. Okay, that is equal to A matrix lo 1 minus 14, 2, 3, 2, 4 minus 14, 6, 3, 6, 9 minus 14 into, this is the vector of eigen. This is a 0 matrix. Simplification, minus 13, 2, 3, 2 minus 10, 6, 3, 6 minus 5 into x is equal to 0. So this is convert to row echelon form. Okay, na? First of all, this element 0, this element 0. Using the operation 13R2 plus 2R1, 13R3 plus 3R1, that is equal to these two elements zeros. Next, this element 0 using R2, or simplification for dividing R2 by 42, R3 by 28, dividing simplification, minus 13, 2, 3, 0 minus 3, 2, 0, 3 minus 2. So next, this element 0. So R3 plus R2. So that is minus 13, 2, 3, 0 minus 3, 2, 0, 0, 0. Okay, now this is row echelon form. So rank is R and number of unknowns 3. So less than 3 kada, not equal. And number of the system has infinitely many solutions. So number of arbitrary values n minus r is equal to 3 minus 2 is equal to 1. The corresponding system of equations, minus 13x plus 2y plus 3z is equal to 0, minus 3y plus 2z is equal to 0. Assumption any y or z is having the arbitrary value. So let z is equal to k1. k1 is non-zero real number. So that is substituting above, minus 3y plus 2k1 is equal to 0. Then y is equal to 2 by 3 k1. Next substituting the above equation, finding x. So that is equal, substituting here, x is equal to 1 by 3 k1. So therefore eigenvector x1 is equal to 1 by 3 k1, 2 by 3 k1, k1. That is equal to 1 by 3, 2 by 3, 1 k1. So you have to common 1 by 3 common. But simplification can easy. 1 by 3 common, 1, 2, 3 t. T is equal to where? 1 by 3 k1. This is the first eigenvector corresponding to lambda is equal to 14. Okay, na? So similarly now finding the second eigenvalue 0. You have to finding same eigenvector. So that is equal to so if lambda is equal to 0, the lambda place lo 0 substitute chain. So matrix equation is Ax is equal to 0. So A is equal to matrix 1, 2, 3, 2, 4, 6, 3, 6, 9. Okay, na? Same, this is converted row echelon form using R2 minus R1. This element 0, this element 0. R2 minus 2R1, R3 minus 3R1. So that is equal to 1, 2, 3, 0, 0, 0, 0, 0, 0. So rank is equal to 1, number of unknowns 3. Okay, is less than 3. So infinite many solutions. The number of arbitrary values are n minus r is equal to 3 minus 1 is equal to 2. corresponding equation x plus 2y plus 3z is equal to 0 kada. Only single equation. Any two variables are having the arbitrary values, y or z or x, any two. Z is equal to k2, y is equal to k3. Okay, now k2, k3 non-zero numbers. That is equal to x plus 2k3 plus 3k2 is equal to 0. Then x is equal to minus 2k3 minus 3k2. So therefore eigenvector I is x is equal to xyz. X is equal to minus 2k3 minus 3k2. Next k3 k2. So this is a column vector separating. Okay na? Two non-zeros together. Two constants together. K2 k3 can be separating also matrix. That is minus 3 0 1 into k2 plus k3 common minus 2 1 0. These are two independent vectors and this is x2 x3. Therefore eigenvectors are x2 is equal minus 3 0 1, x3 is equal minus 2 1 0, corresponding to eigenvalue 0. Okay, now this is eigenvectors for corresponding to given eigenvalues. So now verify orthogonality of these vectors. And x1 vector, x2 vector, x3 vector mutually orthogonal or not. Verify the condition. Using the definitions already చెప్పాను కదా, x1 transpose x2 finding is equal to 0. So that is linearly independent eigenvectors x1, x2, x3. Now verify the orthogonality. So x1 transpose x2 means this is x1 transpose and x1 is the transpose chain 1 2 3 into x2, that is equal to minus 3 plus 0 plus 3 0. Okay, x1 x2 orthogonal. Next to x1 transpose x3. So x1 transpose 1 2 3 x3 minus 2 1 0. So minus 2 plus 2 plus 0 is equal to 0 and x1 x3 also orthogonal. So next to x2 transpose x3. x2 transpose minus 3 0 1 x3 minus 2 1 0 multiplication 6 plus 0 plus 0 is equal to 6. So it is not equal to 0 and x2 x3 both are not orthogonal. x1 x3 orthogonal, x1 x2 is orthogonal, but x2 x3 not orthogonal. So now replacement in the x2 or x3, we have to finding the required orthogonal vector. See that, observing x1 x2 and x1 x3 orthogonal, but x2 x3 are not orthogonal. So now choose the eigenvector x3 and x2 place lo gaane x3 place lo gaane replacement cheyali. We required orthogonal vector. So x3 is equal to, assumption the vector is ABC such that x3 is also must be orthogonal to x1 and is orthogonal to x2. And two equations satisfied must be x3. Okay, now finding x3 new eigenvectors. Okay, so that is equal to x1 transpose x3 is equal to 1 2 3 x3 ABC, that is equal to multiplication 1a plus 2b plus 3c is equal to 0. Next second one, x2 transpose x3 is equal to 0 kada. x2 transpose minus 3 0 1 ABC, that is equal to equation is minus 3a plus c is equal to 0. Now solving equation 1 and 2. So by using this method, a by data of, and a means that a coefficient is deleting remaining, finding choosing the remaining coefficient of data, and b c coefficient. First equation 2 3, second equation lo 0 1. Next to b minus b, and a b coefficient deleting remaining coefficient choosing ac. AC is the first equation 1 3, second equation minus 3 1 is equal to c. C by c coefficient deleting remaining choosing the coefficient ab coefficient 1 2 minus 3 0 is equal to some constant value assumption. So that is equal to a by 2 minus b by 10 c by 6. So a by 1 is equal to 2 చే డివైడ్ చేయండి. a by 1 is equal to b by minus 5 plus c by 3 is equal to t. That is equal to a is equal to t, b is equal to minus 5t, c is equal to 3t, where t is a non-zero real number. So therefore the third eigenvector is assumption x3 is equal to t minus 5t 3t, that is equal t common 1 minus 5 3, the corresponding to eigenvalue is equal to 0. So this is the required orthogonal vectors, and x3 place లో న్యూ ఐగన్ వెక్టర్ రీప్లేస్మెంట్ చేయాలి. దట్ ఈస్ ద దెన్ x1 x2 x3 ఆర్ మ్యూచువల్లీ ఆర్థోగోనల్ ఐగన్ వెక్టర్స్. x1 is equal to 1 2 3, x2 is equal to minus 3 0 1, x3 is equal to 1 minus 5 3. So this is the required orthogonal eigenvectors of the given matrix. Okay, this understood. This question, the long question and important. So eigenvalues distinct అయితే ఆటోమేటికల్లీ ఆ 3 eigenvectors మ్యూచువల్లీ ఆర్థోగోనల్ అవుతాయండి. బట్ ఇక్కడ డిస్టింక్ట్స్ రావలేదు, 0 0 మనకి డిఫరెంట్ వచ్చినాయి కదా ఐగన్ వాల్యూస్, కాబట్టి అది మే నాట్ బి ఆర్థోగోనల్. ఇప్పుడు ఆర్థోగోనల్ కాలేదు కాబట్టి ఫైండ్ అవుట్ చేసినాం. అదే డిస్టింక్ట్ ఐగన్ వాల్యూస్ ఎగ్జిస్ట్ అవుతాయి, ఆటోమేటికల్లీ మ్యూచువల్లీ ఆర్థోగోనల్ అవుతాయండి అవి. ఓకేనా, దిస్ ఈజ్ ద క్వశ్చన్. Okay, thank you. For more videos please do subscribe my channel, like and share it. Thank you.